Greetings everyone, this is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of August 21st, 2023, this time around late summer. And late summer is a great time to see the summer triangle high overhead as it gets dark, just way high overhead as it gets dark, and then look toward the direction of the center of the galaxy in Sagittarius and Scorpius. So we've talked about this a few times this year and in previous years. Why not? You look like you need something to do. So why don't you just go back and watch all of the videos dating back, I don't know, whatever this is now, 2 or 3 years we've been doing this. But you'll see we probably talked about some of this stuff before. We're going to talk about Ophiuchus, the constellation here. It's just this absolute mess on the board. And we'll talk about why it's an absolute mess, and we'll see if we can clarify it just a little bit. But we'll start with the summer triangle. So here's, the moon starts this week about 20-25% full, so it's not very bright. So early in the week is when you want to get out and do most of this observing, and it's going to be impinging on this region of the sky here in, but by Wednesday, Thursday, Friday. So the first few nights of the week are the best. Probably you can still do a lot of this observing on toward Thursday and Friday. By Thursday, the moon is about 60%, 57, 58% full, and it sits right on top of Antares, the orange star in Scorpius here. So that'll be a nice pairing to watch for on Thursday night. But that means Ophiuchus sits right above Scorpius here, so it's going to be getting a little bit bright to do some of this observing that we're seeing. But we're going to be talking about globular star clusters, and those hold up a little bit, at least, to the moonlight. Not great, but a little bit. So here's our summer triangle. Deneb, Vega, and Altair make up the summer triangle. Now, when I'm out looking at the summer triangle, sometimes it looks like the Summer Quadrilateral to me. I see a fourth star there, and that star is Rasalhague, the head of the serpent handler from Arabic. Head of the serpent handler's Rasalhague down this direction. And so sometimes I actually see the summer triangle as more of a quadrilateral like that. And it's a 2.1 magnitude star. So it is fainter than the other 3 stars, but it's a pretty bright star at 2.1. And so I like that star, and it sometimes pops out to me. And Antares sits down below here, the big bright orange star in Scorpio. So that's our first task for the week, is let's get out and identify the summer quadrilateral and find Antares, the bright orange star, down to the south of that. This region that stretches in, that's the head of the serpent handlers right here. It's this top region. Now, this region of the sky, Scorpius, Sagittarius, and Ophiuchus, this is directly toward the center of the galaxy. And one way we deduced it was toward the center of the galaxy is the globular star clusters live in a halo around the center of the galaxy. Globular star clusters are these wonderful star clusters. They're gravitationally bound. We love open star clusters. You see the individual dots of light in open star clusters. But in globulars, what you see is more of a fuzzy ball, because you'll have hundreds of thousands, 500,000 stars all bound together, and they're pretty distant from us, so they merge together into this fuzzy patch where you see some stars around the outlying edges of them maybe. But these globular star clusters, there's the center of our galaxy, there's the disk of our galaxy, and we live out here, right? And all of the globular star clusters live in a halo around the center of the galaxy. I'm just gonna make tick marks here for the next 15 minutes. Just hang on. Okay, enough. That's enough. So we look at it that way. We have to look this direction toward the center of the galaxy to see them. One way we know that. We're looking in one direction that way, toward the center of the galaxy. The center of the galaxy sits on the Scorpius-Sagittarius border. Scorpius, Sagittarius, Ophiuchus above there. So you've got Scorpius, Sagittarius, and Ophiuchus sitting above there. 3 constellations contain over 50% of the globular clusters in the Milky Way. There are 88 constellations that tile the entire sky. So there's a fun fact for you. A constellation's boundaries, it's the bright pattern of stars we think of as the asterism. The constellation is a broader region containing that asterism, and the constellations butt up against each other. So there's no point on the sky that isn't part of a constellation. And 88 of those cover the entire sky. They're different sizes. But if you average them out, Ophiuchus is in fact a very big constellation, but if you average them out and say, they're on average the same, roughly speaking, then you would expect about 388, 4 or 5% of the globular star clusters to be in these three constellations. Instead, it's over 50% in these three constellations: Sagittarius, Scorpius, and Ophiuchus. So we're gonna talk about those globular star clusters. This is how we came to deduce the direction of the center of the galaxy, and this is how we measured the galaxy first time. Harlow Shapley said, hey, if I can measure the average distance to a globular star cluster, I've measured the distance we are from the center of the galaxy back here. So this is fun history of astronomy stuff. It's beautiful observing. But let's try to find the stars of Ophiuchus. So we start with Rasalhague. It's the one that pops out in our Summer Quadrilateral, our newly defined Summer Quadrilateral there. And let's drop down this side. I'm going to try to make this clear. So many globular clusters. That's how this thing got so dirty. It got so stuff exploded on the board because there are so many globular clusters in that region. You start writing them in, and suddenly you can't see anything anymore. So we'll start here, and we'll drop down to Kappa Ophiuchus, a 3.2 magnitude star, Lambda and Delta, 3.8 and 2.7. Epsilon is 3.2. So all of these sort of 2.5 to 4th magnitude stars, relatively easy to see. Not bright. They don't pop out, but they're really bright. You drop down to Zeta 2.5 and Eta 2.4, and then there's a little bit of a drop down here to Theta that is 3.3 magnitude star. We go the other direction, and we have stars that are fainter, so they don't have Greek letters associated with them. We could have put their numbers up there, but we didn't. Board's busy enough. A 3.7 magnitude star, a 4th magnitude star, and we drop down to Nu, which is 3.2 magnitude star. That is. So that's the shape of Ophiuchus, this sort of big loop that we're looking at. And try to identify as many of these stars as you can. Go out, make sketches, take pictures with your cell phone. That's what I love to do. And see what stars we can identify around here of the stars of Ophiuchus. Then we can start looking for globular star clusters. So a couple of the easier ones to find maybe, M107 sits just below Zeta. So you go a couple of degrees below Zeta, and there's M107. Eta, as you drop down from Eta in the direction of Theta, but above the line that connects Eta and Theta, right there is M9. On down, past Theta, in this direction, so you move, I don't know, 4 or 5 degrees off this direction, is M19. So you've got M107, M9, and M19, 3 globular star clusters you can go out and try to find. You might see them, some of these, as little, if you got good binoculars, good big lens light gathering binoculars, 50 millimeter oculars, you might be able to see some of these as little fuzzy, faint patches of light. A small telescope's going to pull them out. The brighter globular clusters are up here in the heart of Ophiuchus. Over by Lambda, move to the interior, and you've got M12 and drop down to M10. And then you scoot across to M14 as you move from Lambda over toward Nu. So sort of draw a line from Lambda to Nu and go a little bit closer to Nu, a fair amount closer to Nu. Or drop down from Beta. We didn't talk about Beta. Beta was a 2.8 magnitude star down in the interior. We just did the loop around the outside. Down in the interior is a 2.8 magnitude star Beta below Rasalhague, and then drop on down to M14 that way. So see if you can triangulate your way into M14. Then if you want a real observing challenge, look next to Nu. About 1 degree is all it is, so it's very close. If you got a small telescope, find Nu Ophiuchi here, and then just scroll up to the northeast a little bit and see if you can find NGC 6517. That's a pretty faint globular cluster. It's going to be a little bit hard to pull out. Really interesting region of the Milky Way there. So if you're looking at this region around Nu, there's all kinds of dark absorbing clouds. So when you look at the Milky Way, it looks like there's big patches where the stars are missing. But the stars aren't missing. There's just big, giant molecular clouds, and there's dust, and there's things absorbing the starlight. And so you see these big blotches of dark where the starlight's being obscured, and this is a really fun region of the sky to scan and do that. So spend a little bit of time doing that as well. Maybe your binoculars show you that as well in that region. So this is a great, see, this is our job this week. Let's watch the moon get brighter and fill out, and watch it scoot past Antares on Thursday night. So Thursday night the 24th, when it's just past half full, the moon is going to scoot past Antares. Then we identify Rasalhague, the head of the serpent handler here in Ophiuchus, as part of a summer triangle extended to a summer quadrilateral, and then we use that to find the other stars of Ophiuchus. and then see if we can find these globular star clusters. A little easier to do in the first half of the week before the moon gets there and brightens up so much. But find as many of these globular star clusters as you can. Think about the history of this. Think about looking toward the direction of the center of our galaxy. We're orbiting the center of our galaxy every 235 million years. And so you're looking right toward the center of that merry-go-round as we orbit around there. And think about what you're looking at there. Think about how, and appreciate that, and all of these globular star clusters that were so important in the history of our being able to determine this. As always, everyone, thanks for watching, and I hope you have some clear skies ahead this week and can get out and do a little observing.